Welcome to qnawire.
Okay, we're going to construct a probability distribution for the data and draw a graph for the distribution. Now, the numbers 1 and 2 don't actually tell me the probabilities, so I can't complete that for you. However, we can do 3 and 4, and then 1 and 2 would be basically the same, but with those probabilities that aren't specified filled in there. Okay, so we'll start with 3. So we have the x values here and the probabilities here. So the x values are 2, 3, 5, 7. So let's go 2, 3, 5, 7. Probability 0.35, 0.41, 0.15, and 0.09. Okay, so if I want to draw a graph for this, we'll go values 1, 2, 3, 4, 5, 6, 7. So anything that's not listed here has probability 0, so it's not going to get a bar. Now I need the bars to go from 0.09 to 0.41. So let's go by 0.05. Okay, so this will be 0.1, this will be 0.2, this one will be 0.3, and 0.4. So then 0.35, this guy, that's the height of 2. We got some kind of bar here for 2. For 3 is 0.41, somewhere around here. For that guy, okay, 4 has 0 probability, 5 is 0.15, so here. That guy, 6 has 0 probability and 7 is 0.09, so somewhere around here. Is for that guy. So that's our graph of our probability distribution there. Okay, I'll do problem 4 next. It will be very similar. Probability ran 0, 1, 2, 3, or 4 DVDs. So we got x and we got p of x. 0, 1, 2, 3, or 4. Probability is 0.15, 0.25, 0.3, 0.25, 0.05. Okay, and then we'll graph that one as well. This one needs to start 0, 1, 2, 3, 4. And again, we'll go by 0.05. This is 0.1, 0.2, 0.3. And then graph it. Okay, so 0 is 0.15, so up here. Something like that. Then 1 is 0.25 up here. And this is also the height for 3. Let's put 1 and 3 at 0.25. 2 is at 0.3. And then 4 is at 0.05. Okay, so that's our graph for the probability there. All right, so that's 3 and 4. Next section, we want to determine if the distribution represents a probability distribution. If it does not, state why. So to check that it represents a probability distribution, we need to check that the sum of the probabilities is 1. So we want the sum of the P of X equals 1. So let's check. So this is 4 13ths, 1 13, 3, 1, and 2. So 4 plus 1 plus 3 plus 1 plus 2 out of 13 is 5, 8, 9, 11 out of 13 is not equal to 1. So not a probability distribution. Okay, so that was the first one. For the second one here, we've got tenths. So it's 3, 1, 1, 2, and 3 tenths. So that's 3, 4, 5, and 5 is 10 tenths. That does equal to 1. So is a probability distribution. Okay, and then the last one here, 0.05, 0.35, 0.4, and 0.2. This becomes 0.4, 0.8, 0.1, just 1, sorry, 0.4, 0.8, 0.8 plus 0.2 will be 1, equals to 1, so it is a probability distribution. Okay, so the first one is not, the next two are. Okay, next part, defective DVDs. From past experience, a company found that in cartons of DVDs, 90% contain no defective DVDs, 5% contain one defective DVD, 3% contain 2 defective DVDs, and 2% contain 3 defective DVDs. Find the mean variance and standard deviation for the number of defective DVDs. So in part 3, problem 1, the mean is the expected value. That's going to be the sum of probability times the number of defectives. So probability 90%, so that's 0.9 times no defectives. Probability 5% is 0.05, that's 1 defective. 3% is 0.03 and times 2 defective. Then 0.02 times 3 defective. That's going to be 0.05, because this is 0, so 0.05 plus 0.06 plus another 0.06 is 0.17. Okay, so the mean is 0.17, so we don't really expect to find the defects, okay? The variance is going to be equal to the expected value of the square minus the square of the expected value. So we take the same calculation here, but instead of multiplying by the number of defects, we multiply by the square of number of defects to calculate the expected value of x squared. Square this, square this, square this, and square this. And then minus the expected value was 0.17 squared. So 0 squared is still 0, and 1 squared is still 1. So we still start with 0.05. Next, 2 squared is 4. 4 times 0.03 will be 0.12. 3 squared is 9. 9 times 0.02 will be 0.18. Okay, so I have to get the calculator for this one. So we have 0.05 plus 0.12 plus 0.18 minus 0.17 squared gives us a variance of 0.3211. Okay, lastly, the standard deviation is just the square root of the variance. It's the variance of x square root. So that will be the square root 0.3211. We'll bring in back our calculator. We want the square root of that value, 0.5667. All right, number 2, cell phone sales. The probability of cellular phone company kiosk sells X number of new phone contracts per day is shown. Find the mean variance and standard deviation for this guy. What's the probability that they will sell 6 or more contracts 3 days in a row? Okay, so for this one, second guy, so the expected value, the mean, is again just summing up the probability times the number of new customers. So 0.4 is probability times the value of 4. 0.3 times probability, is the probability times the value of 5. 0.1 is probability times value 6. 0.15 probability times value 8. And 0.05 probability times value 10. So that's going to be 0. That's not 0, that's 1.6. 1.5. 0.6. And then 1.2 and 0.5. Let's calculate it. 1.6, 1.5, 0.6, 1.2, and 0.5 is 5.4. Okay, so that's our mean. Next, we want the variance. So we do as above. Variance is the expected value of the variable squared minus the expected value squared. So we'll take this, but instead of multiplying by the value, we multiply by the value squared. The value squared, squared, minus what we just got was 5.4 squared. So we'll do this with a calculator. 0.4 times 4 squared is 16, plus 0.3 times 5 squared, 25, 0.1 times 6 squared, 36, 0.15 times 8 squared, 64, 0.05 times 10 squared is 100, minus 5.4 squared, 2.94 is our variance. Okay, then the standard deviation is just the square root of the variance. Is the square root of 2.94. Square root of 2.94. 1.7146. Okay, and then the next thing we wanted in here was the probability that they will sell 6 or more contracts 3 days in a row. So the contract they sell one day to the other is independent. So it's just the probability that they sell 6 or more contracts on one day times the probability they sell 6 or more contracts the next day times the probability they sell 6 or more contracts. Okay, so the probability that X is greater or equal than 6 is, this is discrete. So it's a probability of selling 6 plus 8 plus 10. Plus the probability X is 8. Plus the probability X is 10. So that's 0.1 plus 0.15 plus 0.05. So that's 0.3. So the probability they sell 6 or more contracts on one day is 0.3. So the probability that they sell 3 days in a row is going to be 0.3 cubed. 0.3 cubed, 0.027. Okay, so it's 0.3 cubed is 0.027. So very unlikely. Okay, last one. Solve the following problems using binomial distribution. So I'm going to go ahead and copy this down. So we can have a little bit more room to work with down here. Okay, so driving to work alone, it is reported that 77% of workers age 16 and over drive to work alone. Choose 8 workers at random. Find the given probabilities. So X is distributed binomial. We're choosing 8 of them, and the success probability is 0.77 that they drive to work alone. Okay, so part A is some probability that all of them drive to work alone, so that X is equal to 8. So that's going to be 8, choose 8. Success probability 0.77. I want 8 successes. And failure probability is 1 minus 0.77, which will be 0.23. I don't want any failures, so 0 of those. 8 choose 8 is 1, and 0.23 to 0 is also 1. So this is just 0.77 to 8. We'll get our calculator for that. 0.77 to the power 8. 0.1236. 1236. Okay, part B, more than 1/2 drive to work alone. So what's the probability that X is more than 4, right? I want more than half of them. There's 8 of them, so half of them would be 4, but I want strictly more. So that's the probability that X is 5, plus the probability X is 6, plus the probability X is 7, plus the probability X is 8. So that's going to be 8. Of the 8, I choose 5 of them to have the success, and then 0.77 is success rate. I want 5 of those. 0.23 is failure rate. I need 3 of those because there's 8 total people, so if 5 succeed, 3 must fail. Then for a 6, it would be of the 8, I choose 6 to succeed. Success probability 0.77 to 6, and failure probability, there would need 2 of them. Okay, then for 7, 8 choose 7. Success 0.77, I want 7 of those. And that leaves 1 failure. And then this one we already calculated, 0.77 to power 8. So this is going to be 8 choose 5, the same thing as 8 choose 3. So it's 876 over 3 to 1. So 6 cancels 3, 2. So this is really just 56 here. 8 choose 6 is same as 8 choose 2. 8 times 7 over 2, which would be 28. And 8 choose 7 is just 8. So we go ahead and calculate this with our calculator. So it's 56 times 0.77 to 5 times 0.23 cubed plus 28 times 0.77 to 6 times 0.23 squared plus 8 times 0.77 to 7 times 0.23 plus 0.77 to 8. Okay, so the probability is 0.912. Fairly high probability that over half of them drive to work alone. Okay. C, exactly 3 drive to work alone. So what's the probability that X equals 3? That's going to be 8 choose 3. I want 0.77 success. I want 3 of them. And 0.23 failure. If there's 3 success and 8 total, I need 5 failures. So 8 choose 3, we calculate above here is 56. We'll put this into our calculator. 56 times 0.77 cubed times 0.23 to the power 5. 0.0165. 0165.